Well, hello, Math 3 students. Mr. Eicher here. This lesson 9.4 is a bonus, optional, extended learning lesson. It is not for grade, but the Math 3 teachers like this lesson, but we understand distance learning can be difficult, and it's not an essential lesson, but it would be helpful for those of you who are planning on taking Math 4 next year, also known as pre-calculus at the college level. And eventually, if you're going to take AP Calculus, this might be helpful. Also, it has kind of a cool pattern. Maybe you've heard of Pascal's triangle before, but that's just kind of a cool pattern. Maybe you heard about it in geometry. Again, this lesson will be on the shorter side. You'll see the title is Binomial Theorem Light. There's a lot of other stuff in our textbook that deals with this thing called the binomial theorem. Even in this lesson, I'm just going to talk about conceptually what the theorem does. I won't show you the formula, but you can check out our textbook and look at the binomial theorem formula, which has a sigma notation in it, which we have talked about in this chapter. But let's get started. If you'd like to print the notes, you could do that. So we have, put this down here. So we have expand b plus g to the third. Now that is not b to the third plus g to the third, but as you're aware, we'd want to write it as b plus g times b plus g times b plus g, and then expand that. So distributive property, b times b, b times g, g times b, g times g. So that would be b squared plus 2bg's plus g squared. And we still have a b plus g in there. So when we multiply those two, if we distribute we'll go this way, b times b squared, b times that one, b times that one. That would be, bring it up here, that would be b cubed plus 2b squared g plus bg squared. And then as we distribute the g's, g times that one, g times that one, that would be plus b squared g plus 2bg squared, 2bg squared, and then plus g cubed. And then we add like terms. So there's only one b cubed term, so we're just going to have a b cubed. There are, let's see, there are two terms with b squared g. So there's a 2b squared g and a 1b squared g. So how many b squared g is that? There's 3 of those, 3b squared g. And then we have a bg squared here and a bg squared here. So that's one of those plus 2 of those is 3 bg squared. And then lastly, we have a g cubed. So that's how we expand that binomial. Now, this lesson is going to show you a fast way to expand any binomial, 2 terms, raised to a power. This was a b and a g, 2 terms, raised to the third. There's, I think it's really cool. There's a way to get this answer really quickly without having to do all the multiplying. So the first thing I want to point out is let's look at the terms that have b. So notice the first term has a b cubed, and then a b squared, and then a b to the first, and then no b's, basically a b to the 0. So this pattern is going to hold anytime you multiply, anytime you expand a binomial, you're going to have that descending exponent on the first term. So the first term was b, and it goes b to the third, then the second, then the first, then 0. And notice what happens to the g part of each term. The first one doesn't have any g's. This one is g to the 0, no g's. This one has g to the first, this one has g to the second, this one has g to the third. So the second term, the g, that's going to go uphill on its exponents. So it starts at 0, then it goes to 1, then 2, then 3. So that pattern is always going to hold, which is a really cool pattern. The only other thing is what the coefficients are. So this first coefficient's a 1, this coefficient's a 3, this coefficient's a 3, and this coefficient's a 1. And those coefficients come from something called Pascal's triangle. So before we continue, I just want to show you this pattern in this section of the notes right here. So if we have b plus g raised to the 0, that would be just 1. Any quantity raised to the 0 is defined to be 1. We'll put 1. And I'm putting it kind of in the middle of the page like that, just so you can see this pattern that's going to develop. And now b plus g to the first. Well, that would be 1b plus 1g. And let me, I'm going to move that plus a little bit over here. Okay, so b plus g to the first is just b plus g. I'm going to put the coefficients in there because I'm trying to show you something for later. The next term, b plus g squared, that would be 1b squared plus 2bg plus 1g squared. Again, put the ones in there because I want to demonstrate something to you. But at this point, let's pause and notice the b term, b squared, b to the first, no b's. See how they went downhill like that? And then if you look at the g's, we have no g's, we have 1g, and then we have g squared. So notice this pattern. That's the same pattern that we saw up here in yellow up there. So get rid of that for now. Let's look at the next one. This one is the one we did earlier at the start of the lesson. This one would be 1b cubed plus 3b squared g plus 3bg squared plus 1g cubed. Right? That's what we had up here. If you were to multiply everything out, that's what you get. Again, notice the b cubed, b squared, b, no b's. And then look at the g's. There's no g's, there's 1g, there's 2 g's, there's 3 g's. 3G network, 5G network, I don't know. Now let's look at the next one. The next one, b plus g to the fourth. The first term is going to be 1b to the fourth, right? So the first term, you start with a b, and your exponent is going to be that 4. Now next, I'll tell you what the coefficient is, but there's going to be a way, I hope by the end of the lesson, you can figure out what this coefficient is. This next coefficient is going to be a 4. And do you know what the variable part of the term is going to be? Can you make a conjecture based on the patterns that we've been seeing? Well, we would have a b cubed and a g to the first. Notice that the sum of the exponents, that third and that first, add up to be 4, which is our largest, which is the power we're raising the binomial to. The next one is going to have a coefficient of 6. We'll talk about where that comes from later. But can you figure out the variable part? We're going to have, it was b to the fourth, b to the third. Now we go b squared. And g started with no g's, then it went to g to the first, and now it's going to be g squared. And the next term is going to be a 4. And that's going to be b to the first, g cubed. And then the last term will be 1 g to the fourth. So notice, I just did that. I multiplied that all out. I didn't have to actually expand it and have 4 sets of parentheses and then do all the distributive property like 4 times. No, instead, actually, knowing this pattern, which is based on what's called the binomial theorem, we can expand it very quickly. So let me explain, let me talk about where these coefficients came from. So notice these coefficients, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now these numbers are related to each other. These numbers are what's called Pascal's triangle. Pascal was a French mathematician and philosopher in the 1600s. And he gets credit for discovering this triangle. It was actually discovered long before Pascal, but he gets the credit. So Pascal's triangle looks like this. The It forms a triangle, and you have a 1 at the top, just like we had over there, and then a 1 and a 1. The outer edges of the triangle, the slant height maybe, but the outer edges of the triangle are always 1s. You have a 1, a 2, and a 1, a 1, a 3, a 3, a 1, a 1, a 4, a 6, a 4, a 1. If you'd like to pause the video, see if you can make a conjecture. What do you think the next row? This really, I mean, this triangle goes on infinitely. We could just keep making rows. But what do you think the next row is going to be? So the next row, to be able to figure out what the term is, the outer edges are always going to have 1s. To be able to figure out the next number, the number that would go right here, the way you find that is you take the 2 numbers diagonally above it and you add those. So 1 plus 4 is 5. You take the 2 numbers diagonally above it and you add those, and that's a 10. Take the 2 numbers above it diagonally, and that's a 10. Take the 2 numbers above it and add them, that's a 5. And then I guess my 1's kind of out in no man's land out there. And then a 1. There's always 1s on the edges. So if you know the degree, so if you know that you have a degree 4, you're going to be using the 4th row. You're going to be using the 4th row of Pascal's triangle, the one with a 4 in it. So if we wanted to do b plus g to the 5th, we'd be using this 5th row that I just wrote, 1, 5, 10, 10, 5, 1. And no, you don't really have to memorize those. If you ever use these, you could just write out Pascal's triangle. So since we mentioned something to the 5th, let's look at the next example, x plus 3 raised to the 5th. And we'll use Pascal's triangle to expand that. The way that I like to organize my work that I've found very helpful, I think students find it helpful too. The way that I like to organize my work is I start with the coefficients of Pascal's triangle. So this is a 5. So I'm going to start, and I'm going to go vertically just to keep it organized so it's easier to read. Those coefficients that we just had are these right here. So I'm going to write all those. So we have 1, 5, 10, 10, 5, 1. And next I'm going to write, so these 6 rows represent the 6 terms that I'm going to have once I've expanded everything. Next I'm going to take the first term, which is x. I'm going to start with the highest exponent that it can be, which is a 5, based on this 5. So x to the 5th. And then I'm going to just write straight down descending exponents. So we have x to the 4th, x to the 3rd, x squared, x to the 1, x to the 0. And then lastly, I'm going to take that 3, the second term, and I'm going to start at the smallest exponent it could be, which is 0, and then go uphill. So I have 3 to the 0, 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, 3 to the 5th. And since our term is a plus, each of these terms are going to be positive. And now I'm going to simplify a little bit, and then I'll write all the terms. I'm going to change the color here. So to simplify the first term, 1x to the 5th, 3 to the 0, that would just be x to the 5th. X to the 5th. The next term, we have 5 times x to the 4th times 3 to the 1st. 3 to the 1st is 1. 5 times 3 is 15. X to the 4th. The next term is 10 times x cubed times 9. 3 squared is 9. So that would be 90 x cubed. And then I have 10 times, let's see, 3 cubed is 27. So that would be 10 times 27, 270 x squared. And then I have 5 times 81. 5 times 81. Is that 405? 5 times 81, 405. X. And then lastly, I have a 1. X to the 0 is 1. Uh, 3 to the 5th, that would be 81 times 3, so 243 with no more x's. So our answer, written all out, our answer would be x to the 5th plus 15x to the 4th plus 90x cubed plus 270x squared plus 405x plus 243. So there's our answer. Now, if we were to do that the long way, x plus 3 to the 5th, we would probably still be multiplying everything out. And it also enhances the chance that we will multiply wrong or add wrong or just get lost. It's a lot of work if you actually expanded it by hand. Okay, so that was that one. Let's take a look at x minus 2 to the 6th. Now we need the 6th row of Pascal's triangle, which we did not write up here. So let's go like this. Get rid of that a little bit. Well, maybe I don't want to get rid of that. There we go. So how would we write that 6th row of Pascal's triangle? Well, remember, we're going to have a 1 on the edge. That would be a 1 plus 5 is 6, 5 and 10, 10 and 10, 10 and 5, 5 and 1, and then a 1 on the edge. That's the 6th row of Pascal's triangle. We need the 6th row because we have this exponent, which is a 6. So if you'd like to pause the video and see if you can write out Pascal's triangle. With Pascal's triangle, we just had the values 1, 6, 15, 20. So we have a 1, 6, 15, 20, 15, 6, 1. And we'll take our first term, which is x, and then have x to the 6th, and then go downhill. And we'll take our next term and go uphill. And be careful because of the negative. I'm going to, whoops, that's not uphill. I'm going to use parentheses because we're raising the negative 2. Going all the way to 6. There we go. Now I just need to simplify. So the first term, 1x to the 6th, negative 2 to the 0, that would just be x to the 6th. The next term we have we have 6 times negative 2 is negative 12, x to the 5th. Next we have 15 times positive 4, so that's positive 60, x to the 4th. And next we have 20 times negative 8, which is negative 160, 20 times negative 8. Next we have 15 times negative 2 to the 4 is 16. So we have 15 times 16. I don't know what that is, so let me calculate that. 5 and a 1. So 240. And it's positive. And then we have 6 times negative 32. 6 times negative 32, which is a 2, carry the 1, negative 18. So that's negative 192. X to the 1st. And then 1 times x to the 0 is still 1. Negative 2 to the 6, is that 64? So our final answer for that one, our expanded binomial, will be x to the 6th minus 12x to the 5th plus 60x to the 4th minus 160x cubed plus 240x squared minus 192x plus 64. Just made it. There we go. That would surely take a long time if you didn't have the shortcut with Pascal's triangle and the binomial theorem. There are other applications of the binomial theorem that we won't talk about in this lesson, but if you take Math 4 next year or statistics or AP statistics, then most likely you will see some applications of the binomial theorem. But for this lesson, I'm content if you know two things. Number one, how to create Pascal's triangle, and then how to use Pascal's triangle to do this type of expansion that we have here. Let's look at another example. This one has more variables, so but thankfully we have a small degree, a small power that we're raising it to, the third power. So first we'll look at Pascal's triangle. Look for the third row. The one with the 3 in it is the third row. So we'd start with 1, 3, 3, 1. And then I'm going to take my first term and definitely want parentheses around these since we have a coefficient in front of the x. And we're going to start at 3, the power there, and we're going to go down. And then with the negative 3y, write all those out. And we're going to start at the smallest exponent it can be and work up. So the smallest is 0, and then it goes uphill like that. And then from there, you can pause the video and see if you can simplify correctly. With all the negatives and the parentheses and the powers, it's really easy to miss something. So see what you can do. First, don't write 2x cubed. The first term says 2 cubed x cubed. 2 cubed is 8 x cubed. The next term we have is 3 times 4 times negative 3. So that would be 12 times negative 3 is negative 36 x squared. Oh, and we have a y now. The first one we didn't have a y because it was y to the 0. But now we have a y in there. And then the next term we have 3 times 2 to the first, which is 2, times negative 3 squared, which is 9. So that would be 27 times 2 is 54, positive 54, x to the first, y squared. And then lastly, we have a 1 times a negative 3 cubed, so negative 27 y cubed. So it looks like our final answer is going to be 8x cubed minus 36xy squared plus 54x, sorry, I said squared, x squared y plus 54xy squared minus 27y cubed. There we go. And that's how to use Pascal's triangle with this binomial theorem, this pattern that we've been using to expand that binomial. We have one more example here. I'd encourage you to pause this video to see if you can do the whole works, the whole thing, and I will then just show you the answer at the end. If you have any questions, you can feel free to ask your teachers, but since this is an optional video, don't feel bad if you don't get all the little details, but we do hope that it was helpful. So pause this video and see if you can figure out the answer. There we go. There's the answer I got. 16x to the 4th minus 96x cubed plus 216x squared minus 216x plus 81. Thank you for watching this video. Thank you for taking your time to do an optional extra credit lesson. We should have an assessment so you can earn some points based on what you learned from this video. And hope you enjoyed the video. And hey, give me a thumbs up right below, right? Have a great day.